I want to make sure we have time for the speaker today. So welcome to today's I4 Energy Seminar. Today is the last one of the semester, and we start in the spring semester on, we're scheduled to start January 27th, so we'll see everyone then. So my name is Gaiman Yee. I'm the Technical Director of the I4 Energy Center. Today's originally scheduled speaker, Joe Cubby of UC Santa Cruz, is undergoing knee surgery. So I want to wish him the very best, and I want to thank my colleague Karl Brown, who agreed to speak in his place. Karl is the Deputy Director of CIEE and Director for the CIEE's Energy Use in Buildings Program. As the program director, he plans and manages new technology demonstration efforts that are leading to deep reductions in energy consumption by buildings. Karl's been with CIEE since 1991, has more than 25 years of experience in energy system engineering, and is an expert on deep energy efficiency in buildings. In 2010, Karl was honored as a UC Sustainability Champion for the leadership role in the planning and documentation of deep energy efficiency at UC's new Merced campus. In 2008, he received the Go Beyond Award from the International Institute for Sustainable Laboratories. And in 2003, he was named Energy Engineer of the Year by the Association of Energy Engineers, the Bay Area chapter. Karl has a BS and MS degree in mechanical engineering from UC Berkeley. Let's welcome Karl.
Thank you, Gaiman, and go Bears. Today I have some very interesting technology adoption stories and some numbers from our program. But first, I think some context is necessary. Our program has been running since 2004. It's called the State Partnership for Energy Efficient Demonstrations, or the SPEED program. And we have a relatively new website I'd invite you all to visit to learn more about the technologies and the things we're doing. The sponsor for all of our work, of course, is the California Energy Commission's Public Interest Energy Research Program. And our program is essentially the demonstration arm of the end-use efficiency areas, the buildings area, and to a lesser extent, industrial, ag, and water. We are charged with taking the promising technologies coming out of the PIER program, demonstrating them, and pushing them out into the market. This diagram of our process is a compromise between two models for technology adoption and demonstration. There's the linear or pipeline model, and then there's the feedback model. And today, the success stories that I have will have examples of both, and you can see how they usually work together. The agenda for today, first I have some information about the size, composition, scope, and market impacts from our program. And then I have three success stories to illustrate what are really widely varying paths for different technologies. And I'm hoping to illustrate the flexibility that a program like ours needs to be successful with a range of technologies. Just briefly, the three things I'll be talking about later are data centers, which up until recently, the conditioning for data centers has been fairly slapdash engineered with quite a lot of energy waste. And this is one retrofit approach to cutting down the cooling requirements. The second problem I'll talk about today is lighting for common spaces and lightly occupied spaces. The problem of nobody's there and the lights are still on. And as David Culler likes to say, we need to learn how to do nothing well. The third problem we're talking about today is the general problem that buildings don't work the way we'd like them to, and the remedy for that, commissioning, has a number of issues itself, and we're talking about a new monitoring-based paradigm for building commissioning. So first, the team that it takes to accomplish what we do in the program. It's a large and very talented team. First, we have our project manager from the Energy Commission, David Waitman. From CIEE, which is the coordinator of the program, we have the three Karls, including, especially in the audience today, Karl Johnson, who is really our demonstration program manager and entrepreneur extraordinaire. And so the scale of the program you'll see today is largely due to Karl's efforts. Therese Peffer works on the program for us a bit, and then also in our office, Lo Smith and Jack McGowan. Key partner in our efforts is the California Lighting Technology Center at UC Davis. The two principals, Michael and Kostas, along with the manager for our program, Corey Jackson, lead engineer, Pedro Morani, and Kelly Cunningham, outreach coordinator. The Cooling Efficiency Center has been established more recently and is starting to become a strong partner with its director, Mark Madera, principal engineer, John Woolley, and their outreach director, Paul Fortunato. We've worked with Berkeley Lab extensively on several projects. I'll mention some of the players there as I go today. Early on in the program, Architectural Energy Corporation was one of our major partners. Later on, we were directed to use more university assets, and the cooling center came into being, so we made a shift there. The PG&E Food Service Technology Center is an important partner. California State University Sacramento has recently helped us with a large project at Beale Air Force Base. And our primary set of host demonstration sites, the California higher education campuses, especially including the UC system. So now I'd like to give you a sense of the types of technologies in our portfolio and the range of demonstration sites, but mostly the scale of the program. I've divided up our portfolio into 6 lists. This one is our early interior lighting technology demonstrations, and so from this group, I'll call out bi-level stairwell lighting, which was the first of the bi-level technologies that I'm going to talk about more extensively today. And I'll note that early on in our program, we were demonstrating the CFL, compact fluorescent versions of efficient downlights. As I mentioned, our primary group of host demonstration sites has been UC and CSU, and then later on in 2007, the community colleges. Later, in our interior lighting efforts, I think it's worth noting we've moved on to LED sources for downlights. So even within the tenure of our program, there have been shifts in in the new technology. Here you can see also later in the program we expanded our group of host demonstration sites to include state agencies and other partners. Exterior lighting has become a very big part of our portfolio. Here you can start to see the rest of the smart bi-level technologies. And in this group, you can really see how we've made use of a very important annual event, the California Higher Education Sustainability Conference. That is now involving all California campuses. And in the last 5 years, if you took on the task as a campus of hosting that event, you got a whole cluster of demonstrations on your campus. It's a very effective venue because it gives us a chance to show the technologies to literally hundreds of facility staff from all the California campuses. We've got general application HVAC technologies. We've got specialty HVAC technologies, including the data centers that I'll talk about later, and another important one, demand control ventilation for kitchen hoods for restaurants. And lately, we're being asked to move even further downstream in our deployment efforts and really focus on organizing what we're calling pilot scale deployment of these technologies. That's doing more than just a demonstration of something in a room or a wing of a building. We're talking about whole buildings, whole campuses, whole parking garages, and we've got a number of efforts started there. But I'll mention that our first pilot scale deployment started right at the beginning of our program, monitoring-based commissioning, and I'll talk about that a little bit later. So we keep track of the market potential for the technologies in our portfolio. First, I would look at the numbers on the bottom here. This is the market potential energy savings for the portfolio of technologies that I just showed you if they were deployed in every application in the state of California with 2 levels of penetration, low estimate of 10%, high estimate of 25%. And these are big numbers. I'll focus on the dollars, hundreds of millions of dollars. These are pretty big numbers, but I think the total state energy bill is in the tens of billions of dollars. So we have a significant chunk, but we're still not addressing the whole target. Then we also track the actual and targeted savings from deployments of the technologies we've demonstrated in utility programs, in economic stimulus programs. And we've got 2 categories here, savings that have already been achieved in the books and targeted savings from programs that are currently in progress through 2012. And rolling all that up, the technologies coming out of this program, of what we've documented so far, $26 million a year cumulative annual savings. So we've made a dent in these numbers, but we've got a long ways to go. And we're going to be doing an update of this number. This was actually circa December of last year, so we'll have an update of this soon. So now I'll start with our 3 success stories. The first one, wireless controls for data center HVAC retrofits. Nowadays you'll hear about data centers and shipping containers and all sorts of really clever ideas for improving the efficiency of data centers, but there's still a lot of these legacy rooms, server rooms with crack units, computer room air conditioning units that look something like this, and the conditioning of these spaces is not very carefully engineered, and you get a lot of hot spots and cold spots, and in order to keep everything at the temperature you might like, you're generally overcooling. So backing up a little bit to the origins of this particular technology, in the year 2000, PIER was running its Energy Innovation Small Grants Program, and Cliff Federspiel, who was once with Johnson Controls and for a time spent time in Ed Aron's shop at CBE here at Berkeley, went out on his own and formed his own control company. He had some very clever ideas for control algorithms, and he won small grants from the PIER program. And I'll say that, Cliff's ideas even predated the advent of wireless technologies. So part of what's going on here is his clever controls ideas, but what really made it work later is the wireless technologies that made it cost effective. We started out doing demonstrations of his products, which were for general HVAC retrofits, static pressure reset for variable air volume systems, constant volume to VAV conversions. And I will admit that we were not the first. Paul Black from UCB Facilities, very innovative guy, worked with Cliff early on and was actually the first to demonstrate these technologies on the Berkeley campus. So data centers at that point started to become talked about a lot as a big energy user and a big source of energy waste and big opportunity to save energy. And Cliff applied some of his technologies. At this point, he was starting to use wireless technologies to the problem of data centers. And it's not all about control. It's about various schemes like these curtains to control the airflow in the centers themselves. But it is also about a distributed set of temperature sensors in order to carefully monitor the field of cooling in the data center and apply just enough cooling, just the right units to keep everything at the temperatures you like. Big energy savings here. Huge fraction of the cooling can be eliminated this way. And so I mentioned earlier these two models of technology adoption, the linear model and the feedback model. The linear model sort of assumes this mythical case where you've got a great technology and you fund one demonstration and it's a success and everybody decides that it's a good idea and business picks up, you start using it. That almost never happens, but in this case, it did, because what we did in the SPEED program in 2008 and 2009 is we organized one demonstration at the California Franchise Tax Board, their Sacramento data center. We recruited the Berkeley Lab applications team to do third-party verification and documentation of the demonstration. And there was a big media event in 2009 announcing the results. And this created enough publicity and enough buzz that Cliff was able to get a big ARA grant, economic stimulus funding, to retrofit 12 data centers for the state of California. This business is doing very well. In 2011, their name changed to Vigilant. And probably most importantly, from our standpoint, is this became seen as a successful approach. A lot of demand for the product and the technology, and so many competitors appeared, as well as many competing approaches to data centers. So this to us was a success. One demonstration. Almost never happens that way. Second story today is about a portfolio of technologies that we call smart, bi-level, or adaptive lighting. And as I mentioned, we've got all of these spaces, like stairwells, that are not occupied very much, but the lights are on all the time. So this was actually a New York State Energy Research and Development Authority technology that PIER decided to take a look at as well. It's an integrated bi-level stairwell luminaire with an occupancy sensor and two levels of fluorescent lighting in the fixture. Again, we can't claim to be the first to demonstrate it in California. It was Paul Black putting some of these units in the stairwells in Evans Hall here on the Berkeley campus. But we did go on to demonstrate this on about a dozen UC and CSU campuses. The key enabling research that came out of these demonstrations is, this observation able to demonstrate a very high vacancy rate in these spaces. So it's cost effective to go in and do this kind of control. This is very important when you're discussing monetary incentives for a technology like this with utility program directors. They like this hard data about what we observed in the demonstrations. And one other interesting thing about this technology is the lighting code for egress spaces sort of evolved in parallel with the development of this technology. There was a push at the same time to raise lighting levels in stairwells and other egress spaces. And the people working on this said, well, okay, but write the code to allow a lower level during unoccupied times. Agreement was reached, code was changed, and the stairwell fixture becomes a viable product. So this is a story about a whole family of products that came out of this original bi-level stairwell fixture. We started with interior applications, stairwell fixtures, way back in 2004, the RD&D, and 2005, our NYSERDA and SPEED demonstrations. One key juncture was the first time we were talking with the campuses about buying these fixtures as a part of their utility incentive programs. There was one manufacturer at the time. The campuses each individually went out and got a quote for the pricing of the fixtures, which was not what we were assuming was going to be the mature market cost of the fixtures. The economics didn't pencil out. So we organized the campuses into a group purchase of 1,200 of these stairwell fixtures. We got what we thought was close to the mature market pricing for the fixtures, which was about half of the original quotes. And we seeded the market in that way for this product. Later on, 3 new major manufacturers have appeared, producing products with the same performance characteristics. Pricing is no longer a problem. So this was a unique problem we had to solve for this particular technology. But as I said, it's a bigger portfolio of products. The development efforts moved outdoors because people next realized that we've got a lot of parking lots, parking garages, pathways, other exterior lighting, very low occupancy rates. Lights are always on. So the research was started for what we call the derivatives of this original technology for exterior applications. And you can look at a few of those. This is bi-level parking lot lighting, utilizing, in this case, light-emitting diode sources. We are, in general, lighting source agnostic in our program. This, I believe, are induction sources, but again, bi-level technology in a garage. And so, all this exterior lighting, isn't that nighttime energy use, low cost, low impact? Yes, but in parking garages, we're often saving energy on peak here with these technologies. Here's a photo of what has become kind of an iconic demonstration of this bi-level technology. This is south entry parking structure at UC Davis. And, I'm told that this year Davis sent out its annual Christmas card. And not this photo, but another even better photo of this structure was on their Christmas card this year. A parking garage. That's how cool they think this technology is. So after looking at most of the outdoor applications, we moved back indoors because, gosh, in addition to stairwells, there are corridors. So the RD&D is happening for the corridor derivatives, and we started demonstrations of those derivatives. Here's a demonstration in Boehner Hall at UC Davis. And everything's happening a little bit faster now. We've got these pilot scale deployments that we've talked about planned, and one even started. That adaptive corridor technology is now slated for installation in 11 buildings on the CSU Long Beach campus. And that came about partly because of the ETAP economic stimulus program, partly because of our efforts, and partly because of the sustainability conference that was held there this past June. And as it happens, getting this into standards is happening all at once for all of these different interior and exterior applications. For all of these applications, this is now proposed for the 2013 California Title 24 energy efficiency standards. So we'll still be retrofitting spaces for a long time to come, but hopefully in 2013, this technology will be in every new building. The third success story today is monitoring-based commissioning. Word commissioning, often abbreviated in this way. the chronic problem, buildings don't operate it as intended or desired, and the solution is commissioning. Commissioning is a term. Its definition depends on the context, but in general, it's a catch-all for tune-ups or fixing deficiencies in building HVAC and other systems. And the traditional approach to commissioning, whether you're in new or existing buildings, it's a one-time intervention. It's based on a set of engineering test protocols running through a sequence of operation. The savings accounting has traditionally been based on estimates and assumptions and models. And we've seen that there's a lack of persistence of savings from this approach. And so what we've done is tried to create a paradigm shift for the commissioning industry toward an increased emphasis on monitoring. Monitoring to identify the deficiencies in the measures, monitoring for savings accounting, and monitoring to help assure persistence of the savings. And so we have this cartoon that illustrates the ways in which we think monitoring-based commissioning can actually get you more and deeper savings. This would be the savings from periodic retro-commissioning, energy use of a building over time with an intervention every 5 years to tune the building up. First of all, we think the energy performance monitoring helps the building operators keep a better eye on the performance of the building and catch the problems as they occur. Some of my colleagues like to draw this as a finer sawtooth in here. Second, we think that the metering and trending allows you to identify a whole other set of problems that don't show up in the conventional test protocols. And then we also think that having the metering and trending allows continuous improvement over time. And the other side of the equation is the costs to do this. So there is an increased initial cost sometimes for the permanent monitoring and for the staff training to do this. But perhaps this is replacing repeated commissioning consultant fees. You know, the early research for this started back in the 1990s. Among others, Marianne Piet up at Berkeley Lab decided to apply a finer grain of monitoring to an office building, 180 Sansom Street in San Francisco. So the demonstrations occurred quite some time ago. I dug out this vintage photograph, or this vintage presentation here, just to show this little historical reference here. Monitoring-based commissioning has grown up through a vast change in information technology, and I can remember Marianne exclaiming back in the 90s about this demonstration and telling how they had to pay $10,000 for this high-speed special internet connection so that they could see up at LBNL and at Supersymmetry what was going on at 180 Sansom Street. Things have changed since then. We also noted that some people were having a lot of success with this sort of information-based approach to energy management. This is the efforts of Jim Dewey, the pioneering energy manager at UC Santa Barbara, who took this general approach and reduced the energy intensity of the campus by more than 25% over 5 years. The numbers are the same for natural gas. And here's a little bit more modern implementation of monitoring-based commissioning in a building on this campus, the Tang Hall, the Student Health Services building. This is a trend of total building power. It's a screenshot right off of the campus energy management portal, and I compressed a long time series here, partly to show the persistence of savings. But this is a classic signature of monitoring-based commissioning. First of all, we had no data before August of 2008. The monitoring goes in. The commissioning team studies the building, implements the measures, and we have a drastic reduction in the baseline power of the building, but also an observable reduction in the peak as well. Total savings of over 30% here. You can actually see the extent of the winter curtailment in 3 years on this diagram. In 2008 and 2010, it was a partial containment, and I don't think the health center fully closed during that period. But in 2009, we were right in the worst throes of the initial budget crisis, longer winter curtailment, and I believe the service closed, and you can see they achieved a very clean shutdown during that period. And again, this is one of the classic signatures I use because 2.5 years of persistence of savings with this approach. This is another fairly long timeline. I'll trace the roots of this approach back to efforts by PG&E with thermal energy storage in the 80s and 90s. You have to credit Sacramento Municipal Utility District and Portland Energy Conservation for raising the visibility of commissioning in general by bringing the first national conference to California in '93. CIEE really did the first demonstrations of this at 160 Sansom Street. The PIER program came into being around 1999. The PIER program funded the second demonstration, 925 L Street in Sacramento. Others are working on this as well. Texas A&M, working on their own buildings, captured $3 million of savings back in the 90s. CIEE funded the key persistence study that got people worrying about the long-term effects of commissioning. And the persistence issue is basically why the utilities didn't have retro commissioning programs until around 2004. So 2004, 2005, we organized not a demonstration, but a pilot scale deployment of monitoring-based commissioning, along with the pilot partnership between UC, CSU, and the investor-owned utilities for energy management on all of our campuses. We achieved $2.4 million of savings as a scale deployment in that first pilot effort. We provided technical assistance to that program in the form of a case study and needs assessment, describing some system architectures for performance monitoring, and probably most importantly, a very detailed and scholarly study of the effectiveness of those initial 24 projects, documenting what worked, what didn't. And so that gave the utilities confidence to continue the program. We're capturing another $4 million in the next phase, $2 million in 2009, 2010. There's at least another $6 million of savings available in the two systems. And in the meantime, others are starting to adopt the approach, third-party programs proposing similar programs to PG&E. And probably the future trend are campus energy dashboards. I know of 3 in existence right at the moment. Go online and look at this kind of data at San Diego, Berkeley, and Santa Barbara, and there may be more at this point. I guess the theme throughout my talk today, I've been presenting all these timelines for technology deployment, and these are big success stories. But you can see that this has taken years or decades in some cases, and so my takeaway today is to achieve success in end-use building efficiency deployment. You need concentrated, sustained, committed effort to figure out what's necessary for a given situation and make it happen to get this stuff out into the market. So what's next? What's our next success story? Some candidates. Large system duct sealing with the Western Cooling Center. High-performance rooftop package HVAC units out of the Western Cooling Challenge. Package unit retrofits. Smart thermostats. We're looking at, well, how many people have seen all the publicity about Nest and that? Okay, we're looking at, there are competitors, and we're looking specifically at dormitory applications for those. And so with that, open the floor to questions.
Great. Thank you, Karl. So, do we have questions for Karl? Okay. I'll give Sasha.
Is this on? Testing. Yeah, Karl, I'm curious about the monitoring-based commissioning for buildings. And just if you could give us more of a physical sense of what are the things that you measure in the building and what are the surprises that you've seen as a result of ongoing monitoring in buildings. What are some of the physical measurements that you find, gee, this is not what we thought it should be, but we're discovering this and making changes as a result of this program?
There are a couple of schools of thought of that. Some people like to go for fine-grained measurement of the building subsystems. I'm kind of a top-down proponent myself. I like to look at the whole building signature first, and you can actually see quite a lot, especially about what is going on at night that shouldn't be. To implement this program on our campuses, it was more expensive than usual because our campuses don't have individual building metering, or the building metering needed to be upgraded to equipment that could report up through the web to an energy information system. And I'm generally a proponent of looking at power and energy use itself as the major alarm. Some approaches look at temperatures, space temperatures, actuators, but I find looking for power and energy use where you don't want to see it is the best indicator. It's a short answer to an expansive question.
You mentioned that you're lighting source agnostic, but isn't it the case that some lighting sources experience severe degradations of life expectancy if they're subjected to frequent ons and offs?
The metal halide sources are getting better in that regard because of the competition from LED and induction sources. So they're raising their game. But you're right, metal halide is more degradation, less life expectancy. Sure. But each source has its advantages. LEDs, the point source, sometimes the point source optics is an advantage. Sometimes in certain display applications, it's not what you can use. So we're working with all of them. And they all have a place. They all have an application. David?
So I have two questions. First one is, why does Berkeley seem to be such a laggard? We have lots of nice demonstrations elsewhere. And the other is, in reference to the slide before the last, might we be too mechanically centric, mechanical engineering centric, looking at what to install rather than how better to use what's there?
I would actually say Berkeley is anything but a laggard because, as I mentioned, Paul Black was doing his own internally organized demonstrations of some of these technologies, sometimes first field tests of these technologies on the campus. And Berkeley has been a leader in policy development as well among the 10 systems.
And yet when push comes to shove, it actually seeing savings in buildings. We've got a climate action plan, but a lot of the progress is not.
Well, fully 10% of that $8 million of monitoring-based commissioning savings has been booked at Berkeley. And the persistence issues haven't been solved. The tools are there with the monitoring to achieve the persistence. The utility program design and the incentives and the interaction with that program are after the retrofit model, the one-time intervention model, so there's no mechanism to come back in and support persistence. So we're having to develop internal drivers for that. And your second question was about my emphasis on HVAC and what's next.
Or mechanical in general.
We have had so much success with lighting technologies that we're all hoping for as much success with HVAC technologies. And as I just quickly brainstormed a few ideas, that was my thinking space to write down those ideas. There are solutions for IT systems that we need to solve. There's more lighting to be taken care of. There is certainly more process, our lab systems and our fume hood systems. I think it was just the space I was in that day when I defined that slide.
Question in front.
Ron.
Hi. Two questions. One is, what is actionable in the monitoring-based commissioning in terms of Title 24 standards? What would you expect over the next few years that might be proposed to be Title 24? That's the first question. Second question is, there are a few companies emerging, like Scientific Conservation, that I don't know if you want to call them monitoring-based commissioning companies, but I would like your opinion on whether you think they're going in the right direction to kind of solve the problem you're trying to solve.
The last question first. There are any number of references to monitoring-based commissioning in companies' product literature these days. Some of them are going in the right direction, and maybe some of them are doing things that aren't quite what I described here. A lot of it's going in the right direction. I'm also agnostic about specific providers, specific products, specific companies. Today I think I mentioned only one specific company, Federspiel Controls, because that was so much a part of the story. But I'm gonna be very generic in my technology description. And what was your first question?
What is actionable in the research that you've done on monitoring-based commissioning that might lead to Title 24 standards?
Well, operational standards are a very different animal from the traditional building codes, which are setting standards for creating a capability for efficiency, for achieving efficiency in the building, but are not standards for actually operating the buildings. Commissioning goes a lot more to operations. You can require more monitoring, certainly, and you can require finer grain monitoring, and you can require the capability for data collection. But to go into the operational scenarios, you look more toward the recent legislation requiring benchmarking of commercial office space, which is slowly being implemented. What you're going to see very soon is a requirement for energy use of commercial space to be disclosed upon sale or other major transactions. And that's the regulation that's going to drive commissioning, probably not so much the building codes.